Hello. In this episode, we're going to revisit the first GAN example, which we did in Keras, and let's try to do it with Pytorch and see how GAN is implemented in Pytorch. So again, import the library and the torch libraries. Okay. And the task was, remember, 1010 digit. We're going to create a 1010 digit and have the generator generate such thing. Okay. So the helper functions generate the real data 1010, so a random uniform of 0.8 and 1 between that, so it's close to 1, and then a number close to 0, and then a number close to 1, and a number close to 0. So this is how you generate the real data, and the fake data is just random number 4-digit random number. So the discriminator network, again, we borrow the structure from the NN module of the discriminator. We have a constructor. And the actual network looks like a linear 4 to 3. So input was 4 node, 1010, for example, to 3 node, goes for a sigmoid, and then the 3 to 1, a sigmoid. The 1, the output is basically 1 if it's real, 0 if it's fake data. The loss function is MSE loss, so it's a loss function here. Optimizer is a stochastic gradient descent optimizer. We have a counter. The forward path is simply the model itself. And here's the training part of the discriminator network. The training is forward path of input, get the output. So it goes through the neural network and it gets the output. The loss function is computed. And then the loss optimizer set to gradient 0. And then the loss backward computes the gradient, optimizer step, we'll update the weights, and we keep doing this. Okay, so this is a discriminator network. You can test the discriminator. Okay, so D equal discriminator. So we construct it, and then D train generate real sample and train it on that. So we get real sample and train it and tell that it's a true sample, torch flow tensor 1. So we give 1 to signal that it's a true sample. And here, get a fake sample and tell that it's a fake sample and train the discriminator. And you can plot it. The plot had a progress plot function, remember? The plot progress, you can actually plot them. And it looks like the error is decreasing. Okay. So for real sample, if you test it, it gives a number close to 1. It's a real data. And if it generates a fake sample and give it to discriminator, it gives a number close to 0, saying it's a fake data. Similarly, generator, after an initiator, constructor, you get a sequential network of 1 random number. We blow it up to 3 nodes and the 3 nodes to 4 nodes. That's the output. And send it to sigmoid, okay, to make a number between 0 and 1. We have an optimizer of stochastic gradient descent. And the training is, well, you have a network forward output, and the output goes through a discriminator, get the D output. The loss is the output and the target. Okay, so calculate the error. And then 0 gradient, and then backward of the loss, and then optimizer step. Okay. So this is how you do the generator. You can test the generator and give a float tensor 0.5. With the 0.5, it generates just a random number. We have trained them much, so it's just a random number. Now the GAN. Okay, so you want to train the generator such that it fools the discriminator. How do you do this? First, you declare the discriminator and generator. You create them. The discriminator generate on real sample and tell that it's a real sample 1. And then you train the discriminator again with a generator created with the random seed of 0.5, and you detach it. We don't want to get the gradients there, and tell the float tensor 0. So this was training the discriminator on the fake data. Then we train the generator with the discriminator and torch float tensor 0.5, which is the random number, right? And a torch float tensor 1, which tells you fools the discriminator that it is a true data, although it's a fake data. Okay? So you keep doing that. And you train it. Okay. All right. So this can take a while. So let's come back when it's done. Okay, the training's done. So let's plot the progress of the discriminator. It goes into 1/4, 0.25. And there's a good reason for it. This is the mean square error. The generator and the discriminator are competing and in stalemate. It should be 0.5. The 0.5 of the square, the mean square error, will get you 0.25. Okay. You plot the generator will do the same thing, isn't it? It gets half of the error. I'll square them. You will basically get a quarter. Okay. So manually running the generator from a seed of 0.5 to the tensor, create generator, create a number. It gets you 0.95, 0.02, 0.96, 0.2. So it does create a number that looks like 1010 pattern. You can even visualize for multiple of them. And you can see that the training process, how the image looked like. Originally, it was kind of not clear what a random number pattern, but after a while of the training, you can see that it becomes more of a 1, 0, 1. The darker colors are 1, brighter colors are 0, or closer to 0. So 1, 0, 1, 0 pattern is being done. Okay. So this is the revisiting the GAN example, but instead of Keras, we use Pytorch to do it. Thank you for watching this episode.